In today's lesson, we're going to take a look at standard ES1, charging and methods of charging. And to start off, we're going to take a look at the different things that make up electrical charge, specifically the parts of atomic structure. You may remember from chemistry, when they talk about atoms, they have a couple different types of charges that we look at. We have the proton, which constitutes and contributes a positive charge to any atom, neutrons, which contribute no charge, and electrons, which contribute negative charges. In this lesson, we're going to take a look at how these protons and electrons specifically, because they're the charged particles, contribute to having particles and objects become electrically charged themselves. And here's a picture of an atom, obviously not scaled because of the size of the nucleus, that's showing electrons in the outer shells of the electron, where the protons and neutrons are in the nucleus. So let's talk about how these electrons and protons contribute to electrical charge of particles. So we're going to look again at ES1, charge and charging, and we're going to define what charge is, and that is the difference between the number of electrons and protons found in an object. So every electrical charge that we're going to talk about from here on forward is always going to be based on this idea that charging itself comes from this electron-proton imbalance. In order to quantify charge, we're going to use the symbol Q, lowercase q, to represent charge. When we talk about charge is going to be measured in a unit called coulombs, and we're going to use the symbol for coulombs as the capital C, and we're going to talk about how charge in coulombs is developed. Now, when we talk about charge, there's two different types of charge that we can find. We have positive charge and negative charge. When we talk about positive and negatively charged particles, one of the most important concepts to understand, and it's going to explain a lot of electrical phenomenon, is that charges that have similar signs, either two positively charged particles or two negatively charged particles, will feel forces of repulsion between them. And then charges that have opposite signs, like a negatively charged particle and a positively charged particle, they will feel forces of attraction. So you might have heard the phrase before, opposites attract. This is talking about negative and positive charges when you talk about electrical aspects. Now, when we talk about objects that are becoming charged themselves, it's important to note the role of electrons in this. Protons are caught in the nucleus of an atom, and so they don't have the ability to move themselves. So when we talk about charges, they always have to come from some sort of electron movement. Now, if we want to become negatively charged ourselves, or if we want to look at a negatively charged particle or object, that object's got to become negatively charged because the electrons are gained by the object. So if it's negatively charged, that means it has too many negatively charged particles being electrons, more so than the protons. So more electrons than protons, electrons being gained, that's a negative charge. Contrary, if you look at the positive charge that develops on particles or objects, protons carry positive charge. They can't move between atoms and objects. So if an object is becoming positively charged, it's because it's lost electrons. So let's talk about one of the main fundamental laws of conservation when we talk about electric charge, and that is the idea that charge is always conserved. We don't create charge. Every object has, if it's neutral, same amount of protons and electrons on the object itself. So we don't create charge. Neutral objects become charged by transferring electrons back and forth. So we said this on the previous slide. Positively charged particles occur when you lose electrons, and negatively charged particles occur when they have a net gain of electrons. We want to quantify the amount of elementary charge there is, and protons and electrons have the same fundamental amount of electrical charge. So one proton and one electron would cancel each other out because the contribution from the proton and contribution from the electron, both one positive, one negative, would cancel one another. So we say that each one of these fundamental charge-carrying particles of proton and electron both are a multiple of some fundamental elementary charge, and we give this elementary charge the symbol E. Oftentimes we'll talk about electrons having a negative elementary charge and protons having a positive elementary charge. And each one of these particles, both a proton and an electron, have a magnitude of elementary charge that is 1.6 times 10 to the negative 19 coulombs. So whenever we see charge on a particle, they always have to be some sort of ratio or some sort of ultimate amount of elementary charges of imbalance. And that means all charges themselves that can occur on a particle have to be some multiple of the elementary charge, 1.6 times 10 to negative 19 coulombs. The electron would be negative 1.6 times 10 to negative 19 coulombs, where the proton would be a positive 1.6 times 10 to negative 19 coulombs. So let's take a look at an example of this. If we have an object that has an excess, meaning it has an 5.0 times 10 to the 6 electrons, so it has that many more electrons than protons, we want to figure out how much actual charge is developed there. Each electron has a charge of negative 1.6 times 10 to negative 19 coulombs. To find the charge, we take the charge per electron, and we would multiply the charge per electron by the number of excess electrons, finding a total charge of negative 8.0 times 10 to negative 13 coulombs of charge.